So in today's video, we're going to be looking at simple trinomials. Now, a simple trinomial just looks like the following. We're going to have ax squared plus bx plus c, where a, b, and c are coefficients. Now, what makes a simple trinomial special is that our a coefficient must always equal to 1. Okay, so that's going to be actually our first rule of simple trinomials, is that a must be 1. Now, b and c can be any number we want them to be. So let's have a look at an example here. So let's say we have x squared plus 5x plus 6. So how would we go about factoring this? Well, this gets us into our second step, which our second step, or our second rule, is just going to be we need to find two numbers that multiply to 6, but also add to 5. So we need to find two numbers that multiply to our c term, which in this case is 6. So multiply to c and add to b. Okay? So in this case, right, what do we think this would be? So let's go through some options here. So if we have x squared plus 5x plus 6, well, what can multiply to 6? Well, 2 and 3 can multiply to 6, or 6 and 1 can multiply to 6. So if we think about this now, these numbers need to also add to 5. So 6 and 1, if I add those, they're going to add to 7. So that's not correct. But our 2 and our 3, if we add those together, they're going to equal 5. So our first answer is just going to look like the following. We're going to put equals x plus 2 bracket x plus 3. And right there is our answer to our first simple trinomial. So if we go on to this next page here, let's try another one. So let's say we have x squared plus 7x plus 10. Right? So once again we check, well, our a is just equal to 1, and we have our b and our c terms. Now let's think of numbers that multiply to 10. Well, how about 5 and 2? And if I add 5 and 2, I'm going to get to 7. Okay, so same thing again. We're going to write out our final answer as bracket x plus that first number, which is 5, and then bracket x plus that second number, which is 2. And that's our answer to our second question there. Okay, let's go on to a third one here. Let's say now we've got x squared plus x minus 12. Okay, so in this case, our a term is still equal to 1. Our b term here, right, if we think about what that would be equal to, well, that's just equal to 1 as well. And our c term is equal to 12. So now let's think of two numbers. And actually, our c term is not just 12, it's negative 12. So what are two numbers that multiply to negative 12? Let's think about this. So we have, negative 6 and 2. And if I try to add these, well, that's going to equal negative 4. So that's not it there. So let's try a different set of numbers. How about negative 4 and 3? Okay, well, if I go to add those, I'm going to get negative 1. But we're looking for positive 1. So this as well doesn't work, but we're close. What if we try flipping them around? Meaning, instead of negative 4, we do positive 4 and negative 3. Now, if I imagine I add these numbers together, well, 4 plus negative 3 is just the same as 4 minus 3. So that will equal 1, which is what our b term is. So for this one here, we write out our final answer as x plus 4 bracket x minus 3. Right there, we've got our third one solved. Okay, let's go on to our fourth one here. Let's pull up another page. Okay, here we're going to try y squared minus y minus 30. Okay, So let's think through this one here. So we first check, well, our a term is just equal to 1 again. Our b term is equal to 1. And our c term is negative 30. Okay, and by the way, just because now we're looking at y squareds and y instead of x's, that doesn't matter. As long as we're looking at like terms, meaning everything's a y or everything's an x or everything's an a, then we're able to factor it this way. So now we need to think of two numbers that multiply to negative 30. So let's think of some here. Well, how about negative 10 and 3? If I go to add those, I'm going to get negative 7. Okay, so that's not it there. So let's think of some other ones here. How about negative 15 and 2? If I add those together, I'm going to get negative 13. Okay, that's not it either. So let's think of some other numbers here that add up. How about negative 6 and 5? If I add those together, I get negative 1, which is what we're looking for. So now that I have that, we can write out our final answer again. So this is equal to x minus 6 bracket x plus 5. Okay, now let's get into our last practice question here. For this one, we're going to have 2a squared minus 16a plus 30. Okay, so right off, what do we recognize that's different about this one? Well, our a term, that first leading coefficient there, isn't 1, it's actually 2. So right now, this isn't a simple trinomial. We can't factor it the same way as we usually would, where we'd find two numbers that multiply to 30. But if we think back to the factoring that we've learned, the first factoring that we learned is common factoring, meaning is there a number that we can divide out or factor out of all of these numbers? So let's think, well, 2 can only be divided by 2 or 1. 16 can be divided by 2, and 30 can be divided by 2, meaning we can factor that 2 out. So we're going to be left instead with 2 bracket. Now we're left with a squared minus 8a plus 15. So now that we factored out the 2, this right here looks like our normal simple trinomial. So let's think of two numbers that multiply to 15. How about 5 and 3? Well, if I add those, I get positive 8. Okay, well, we need to get negative 8. So how about we just try flipping both of these signs around? So instead of positive 5 and positive 3, we do negative 5 and negative 3. If we add those together, we will get negative 8, meaning our final answer is just equal to, we need to keep that 2 there. We'll have 2 bracket x minus 5 bracket x minus 3. And that right there is how we're going to factor all simple trinomials.